Here, the method for calculating the reaction forces. When a concentrated action force acts at the center of a simply supported beam is explained. A simply supported beam is a statically determinate structure with 3 reaction forces and no intermediate hinges, so all reaction forces can be calculated by the equilibrium conditions of forces in 3 directions. Objects around us that are at rest must satisfy the equilibrium conditions of forces in 3 directions. The simply supported beam, to be discussed, has a roller support at A, a pin support at B, and a length of L, as shown in the figure. The reaction forces are determined when the vertical action force P shown in the figure is applied at the center point C of the span. For a beam, a free end allows movement in all directions: vertical, horizontal, and rotational. A roller support allows the beam to move freely in the horizontal and rotational directions, but it restricts movement in the vertical direction. A hinge support allows the beam to rotate freely, but restricts movement in both the vertical and horizontal directions. A fixed support restricts movement of the beam in all directions: vertical, horizontal, and rotational. Steps for determining reaction forces. Step 1. Create a free body diagram of the reaction forces. Step 2. Determine all the reaction forces by applying force equilibrium in the 3 directions. Step 1. Create a free body diagram of the reaction forces. The roller support at A restrains the vertical movement of the beam, so the reaction force at A is given by the vertical reaction force VA that restrains vertical movement. The hinge support at B restrains both the vertical and horizontal movements of the beam, so the reaction forces at B are given by the vertical reaction force VB that restrains vertical movement and the horizontal reaction force HB that restrains horizontal movement. The directions of the reaction forces are assumed as follows: VA is upward, VB is upward, and HB is to the left, as shown in the figure. Step 2. Determine all the reaction forces by applying force equilibrium in the 3 directions. We will now analyze the equilibrium of forces in the vertical direction. Refer to the free body diagram of the reaction forces for the vertical forces. The vertical forces are VA at point A, P at point C, and VB at point B. We will derive the equilibrium equation for these forces. In the vertical force summation, forces acting upward are considered positive. Let's clarify this. The force at point A is upward, hence plus VA. The force at point C is downward, hence minus P. And the force at point B is upward, hence plus VB. To achieve equilibrium of these vertical forces, their algebraic sum must be 0. This concludes the discussion on vertical forces. We will now analyze the equilibrium of forces in the horizontal direction. Refer to the free body diagram of the reaction forces for the horizontal forces. The only horizontal force is HB at point B. As HB is the only horizontal force, the equilibrium equation can be expressed as follows. We will now analyze the rotational equilibrium of moments. First, examine the lines of action of all forces. The lines of action are as follows. The line of action for VA. The line of action for P. The line of action for VB. And the line of action for HB. Next, select the center of rotation. Choosing a point through which as many lines of action of the unknown reaction forces pass as possible will simplify the calculations for determining these reaction forces. In this case, we will select point B, through which the lines of action of the unknown forces VB and HB pass, as the center of rotation. Then, calculate the shortest distance from each line of action to the center of rotation at point B. This shortest distance will serve as the arm length of the moment for each force relative to the center of rotation. The arm length for the force VA is L, and the arm length for the force P is 1/2 of L. Since the line of action of VB passes through point B, the arm length for VB is 0. Similarly, the arm length for HB is also 0, as its line of action passes through point B. We will now derive the equilibrium equation. In the summation of moments in the rotational direction, clockwise moments are considered positive. The center of rotation is point B. Let's clarify this. The force VA acts clockwise round the center of rotation, hence plus VA times L. The force P acts counterclockwise around the center of rotation, hence minus P times 1/2 of L. Since the arm length of VB with respect to the center of rotation is 0, hence 0. Similarly, the arm length of HB with respect to the center of rotation is also 0, hence 0. To achieve equilibrium of moments, their algebraic sum must be 0. This concludes the discussion on rotational equilibrium. Through the equilibrium of forces in three directions, the reaction forces VA, VB, and HB are determined as follows. The calculated signs are based on the free body diagram on the left. The positive sign of VA indicates that this reaction force acts upward, consistent with the vector assumed in the free body diagram. Similarly, the positive sign of VB indicates that this reaction force also acts upward, as assumed in the free body diagram. Since HB is 0, there is no direction associated with it,